Good evening, ladies and gentlemen. We are on our second lesson for Unit 9, and our lesson is volume. And if you notice, it covers a whole bunch of SWAN lessons. So we're actually going to be covering multiple lessons in this one, which means this one lesson is very, very important. So our goal is, today I will find the volume of rectangular prisms using a variety of methods. Okay, that's quite a goal with a lot of vocab in it. Okay, so our first word is, what is volume? If this is the title of our lesson, what does volume even mean? Volume is the amount of space inside a three-dimensional object. So it's the amount of space inside a three-dimensional object. So a lot of times when they talk about volume, especially on test, they'll talk about maybe like how much could fit inside a fish tank, how much water could fit inside the fish tank. So it's what you put on the inside. Okay, our next word is cubed. Okay, all of your answers for volume are going to be cubed. So our answers for volume are something called cubed. Okay, what that means is, if we were measuring in inches, we would have an exponent of 3. Maybe if we were measuring in feet, we would have an exponent of 3. Okay, it could also be, though, that if we're measuring in units, we could have units cubed, or they actually might write the word cubic units. And later on, I'll explain why that is. And I'm going to scoot that over, sorry. I will explain why our answers are going to be always cubed or in cubic units. So whatever our measurement is, it could be inches, it could be feet, it even could be like centimeters, we would do a cubed. Or if it was, we could also have like meters cubed. So whatever your measurement is, we're going to have it cubed, which means an exponent of 3. Which means it's inch times inch times inch, or centimeter times centimeter times centimeter. Okay, our next word is rectangular prism. So our goal was, we're going to be finding volume of rectangular prisms. In 5th grade, that's really the only shape we work with. Pretty much a rectangular prism, right here, if we think about a rectangle, it's a 3-dimension, and I'm just going to put 3D, and it's a box. It's a perfect box. So our box could be something, if you picture maybe like a Kleenex box. It's a rectangular, it's a 3D rectangle. Or it could be even a cube, like a dice or a die, because it's 3D rectangle. But it's pretty much a box, which means it's going to have sharp corners or vertices and straight lines. Okay, our last vocab word is just a review of area. Okay, area is when we find length times width, and we find it of two-dimensional shapes. You find area of two-dimensional shapes, and we did this on our last unit test. Okay, the answer for area is not going to be cubed like volume. The answer is something we called squared. So it would be like inches squared, or feet squared, or centimeters squared. So our exponent is a 2, whereas with cubed, the exponent is a 3. Okay, we're going to move on to our notes. Okay, our first note is something kind of silly, but height. This seems to confuse people about the height. When you think of height, I want you to think about your height. If you were measuring your height, would you ever lay down to have your height measured? Absolutely not. Would you ever lay up against a wall crooked to get your height measured? No, that would be crazy. When we measure height, it's always a straight up and down, completely vertical up and down. So when you're looking for the height of our shapes, you need to remember that. You need to remember height is always up and down, just like how your body would be if you were having your height measured. So height is always going to be straight up and down. Okay, so for volume, we're going to be focusing on two formulas. These are called formulas. So I'm actually going to write the word formula and point. So when I'm talking about formulas, these are our two formulas. In math, formulas just mean kind of rules you follow. So this isn't my shortcut or my trick or something I made up. These are actual mathematical formulas that will work on every problem if it's done correctly. Okay, so our first formula is what we call volume. So we're looking for volume, and a way you can find volume is volume equals base times height. Okay, when we talk about base here, they mean base is the area of the base. So we call it base, but they're really saying it's the area of the base. Okay, now when we write this as a shortcut, we don't write out the words, we actually usually write out the letters. So what we'll see for this is we'll see V for volume equals B for base times H for height. That is your formula right there. Okay, our second formula is what we call volume equals length times width times height. Okay, now this one they shortcut again using letters. So volume equals, now instead of a straight L, which might get confused for 1, they usually put it in cursive. Volume equals length times width times height. This is our second formula. So those are the two formulas we're going to be using to find volume of our shapes. Okay, our steps are only 4 and they're pretty short. Our first step is we're going to write the formula. Okay, and when I say formula, it's these two that we already are talking about. I'm going to write my formula. Then I'm going to fill in the numbers. Okay, my third step is I'm going to solve, but I'm going to solve one step at a time. And my final step is I'm going to add measurement cubed. So if my measurement was in feet, it's going to be feet cubed. If it was in units, it's going to be units cubed. But I'm going to make sure I put that little 3 exponent to show that I understand that volume is units cubed. Okay, so what does volume really look like? I'm going to explain it a little bit more in detail with mine. My modeling looks a little different today because I wanted to show you a lot. So here's my first problem. My problem says find the volume of this rectangular prism. Okay, so what I want to show you really quick though before I get started is, remember, volume means how much can fit inside. That's what they're asking you. How much room is inside that box? And notice this is my rectangular prism, my box. Okay, So what they're really asking is, the reason my answer is cubed is we're going to kind of pretend that we're going to fill this box with tiny little cubes. Okay, so to get started, I kind of broke this one down for you because I want you to see lots of parts at once. Okay, so what I did here is I just kind of colored this bottom in for you. I want you to see, this is what we call the base. So in our formula, when I talked about the base, I mean the bottom. So this is the bottom of my rectangular prism. Right here, I just drew it flat for you. So here's the 7, and then here's the 4, which is right here. Now they don't have a 4 there, but if you think about this being a box, if this is 4 on this side, and that's the top, the bottom would have to be 4 there too. Because on a box, the top and the bottom are the same. So this is just the bottom of my box, which we call our base. That's the base of my box. Okay, so just to go a little further, what volume really means, and this is where this cubed comes in again, is we're really going to pretend that we're filling this bottom with cubes. We're going to actually fill the whole shape with cubes. But if you notice the 7 here, I could put 7, 1, 2, 3, 4, 5, 6, 7 cubes along that one. This one's a 4, so I could put 1, 2, 3, 4 cubes right along there. And then I could tuck them all in and I could fit all of these in there. So if we really were going to count all these, I have 7 in this row, 7 here, and 7 here. So I'm seeing that I have 28. So I could, on the base of this, I could fit 28 little cubes. Okay, but if we think about this, that's just going to be the base. It tells me I can, remember we said our height is our straight one, our up and down. So my height of this shape is 4, which means I could also put 4 cubes on the height. So what volume really means is this is what I'm doing to it. I filled up my base, and then I can go 4 units high. So notice I'm going to go 1, 2, 3, 4 high. Well, if my base was 28, how many do you think is in each layer? Hopefully you're thinking each layer is going to have 28. So I can fit a layer, if I go back to our original question, 1 layer of 28, 1 layer of 28, 1 layer of 28, 1 layer of 28 up here. So I can actually fit a lot of little cubes in my shape. Now, obviously this is not efficient at all. We're not going to want to solve by trying to somehow break it up and draw little boxes. This is a really sophisticated picture to draw. But I just wanted you to really get the idea of what volume means and why the answer is called cubed, because we're going to pretend we're filling it with little cubes. Okay, but as we just said, that's not efficient. So what's an efficient way is to use our formulas. Okay, before we actually do our formulas though, let's skip back to this. If each layer had 28 and we said there's 4 layers, how many little cubes are there? Let's see, I'm going to just multiply, and I'm getting 4 times 8 is 32, 4 times 2 is 8 plus, I'm saying this whole picture here has 111 little cubes. Okay, let's see if we could do this in an efficient way using mathematical formulas. Okay, so my steps say I'm going to first write my formula. Now I have 2 to choose from. So I'm going to choose this first one, and then we'll do the other one. So my formula is volume equals base times height. So volume equals base times height. Okay, my second step says fill in the numbers. Okay, well, if this is a 4, because we had already said they would have to be the same, what's my base? Well, when I find base, remember we said we're finding the area of the base? So what's the area of this bottom part? Well, we've learned area is 7 times 4, which is 28. So my base is 28, and my height is my straight up and down number, just like measuring our own height, which is 4. So I just did step 2. I filled in my numbers. Step 3 says I'm going to solve one step at a time. Well, for this one, there's just one step, and it's 28 times 4. Well, I know what 28 times 4 is because I did it earlier. 28 times 4 is 112. So I've solved it, and my final step is I'm going to add my measurement cubed. So this one, my measurement's called units. So it's units cubed. Okay, now, if I think about it, it really was my picture. It was just kind of a shortcut of my picture. I could have also done my other formula. I could have also chosen this formula. It really would not have mattered. We need to know that they're the same thing, but I'm going to show you why they're the same thing. So if I choose my other formula for step 1, and then step 2 I fill in my numbers, my length is 7, my width is 4, and my height is my straight up and down number is also 4. And then for step 3, when I go to solve one step at a time, look what I end up with. The same thing. So all this one is they've taken my length and width and combined it. So they've taken my length and width and combined it. But you will get the exact same answer when you solve it. But you really need to be comfortable with both answers. I'm sorry, with both formulas. Okay, so I'm going to show you one more a little bit quicker this time. This one just says, find the volume of this cube. Ooh, now they try to get tricky because they only gave me one measurement. But if it's a cube, I know that cubes have all sides the same. That's what a cube means. A cube means every side is the same. Now, I kind of showed you the pictures. Layer 1, I could put 2 in front and 2 on the side. So look, I could put 4 little cubes. And then it's too tall. Remember, my height is that. So I could make 2 tall. But we're going to actually, remember, use our formula because that's what matters. So my formula is volume equals base times height. My base, I could look here as 4, or I could say 2 times 2, my bottom's going to be 4 on the bottom, and then my height is 2. So I'm getting my answer is 8 units cubed. Okay, now the reason